2. Quick review. First derivative test tells us if a function is increasing or decreasing by the sign of the derivative. If the derivative is positive, our function is increasing. If the derivative is negative, our function is decreasing. Find the relative extrema. Now those are the max or min. We find those by looking at the sign changes of the derivative. So let's do that. Let's find the relative extrema. First off, we need to find our derivative. All right, so here we use the product rule with a chain rule. So this would be 2 times x minus 1 is the derivative of the first. The second we'll leave alone. Plus the second times the derivative of the second, which is 1, times the derivative of the first, which is x minus 1 squared. Set that equal to 0 and solve for x. This might be easiest to set equal to 0 if we factor x minus 1 from both sides, or from both terms. So factor x minus 1 from both groups. The first group, we're left with 2. Distribute that to x plus 2, we got 2x plus 4. And over here in the second group, we're going to have one of the x minus 1s left. So when we set our derivative equal to 0, it's x minus 1 and 3x plus 3, which is 3 times x plus 1. And so we can see our critical numbers are x equals 1, x equals negative 1. All right, so now we will set up our test intervals. All right, remember the number line goes from negative infinity to infinity with these critical numbers in between. We'll check our first interval. Let's use negative 100. I'm using the derivative, the easiest form to use is right there. If I stick negative 100, I'll stick negative 100 in here. Negative 100 minus 1 is negative. Using 3x plus 3, if I stick negative 100 in there, it's negative 300 plus 3, which is negative. A negative times a negative is a positive. For my interval from negative 1 to 1, easiest number to pick there is 0. So I'll plug in 0, effectively canceling off the x's. That gives me negative 1. That gives me 3. Negative 1 times 3 is negative 3, which is negative. And I'll check my last interval. Let's pick 100 there. Substituting 100 into x minus 1 gets me 99, which is positive. Substituting 100 into 3x plus 3, I get 303, which is positive. A positive times a positive is a positive. And I can see my relative extrema right here. The sign changes from positive to negative. That is a relative max. Right here, my sign changes from negative to positive. That is a relative min. And I need to be more specific on the AP exam. I need to sit there and explain it better. So what I'm going to do is I'm going to say there is a relative max at negative 1, should better be x equals negative 1. And if they asked what it was, you would want to substitute that in. If I substitute negative 1 in to find it, we get negative 1 minus 1 is negative 2 squared is 4. Negative 1 plus 2 is 1, so that's 4. So there's relative max at x equals negative 1 of 4. And then because f prime switches from positive to negative, And conversely, there is a relative min at x equals 1. And again, we can find it by plugging it in. 1 minus 1 is 0. Once we get 0 in a multiplication problem, we can stop. There is a relative min at x equals 1 of 0 because the derivative switches from negative to positive. Good. All right. So you're going to find your critical numbers, test your intervals, give your answers with reasons. All right. The position of a particle on the x-axis is given by x of t equals t cubed plus 1/2 t squared minus 4. When is the particle moving to the right? In other words, when is the position increasing? All right. So to find that, we want to find the velocity when the velocity is positive. So we have position. Velocity is the derivative of position. So our velocity will be 3t squared plus t. We can set that equal to 0. We'll factor out 3t. We're left with t plus 1. Our critical numbers are 0 and negative 1. If we check our intervals, okay, using negative 100, we get negative and negative. So from negative infinity to 1, it's increasing. If we stick in negative 1/2, we get negative, positive. So here it is moving left from negative 1 to 0. And from 0 to infinity, if we stick in 1,000,000, we have positive and positive, positive. So it is moving to the right on the interval negative infinity to negative 1 in union with the interval from 0 to infinity. Because velocity is positive. What is the minimum velocity? Well, here we want to find the extrema of velocity. Well, to find extrema, we need to find the derivative. So we need to find acceleration. A of t equals 6t plus 1. Set that equal to 0. We see that t equals negative 1/6. Make a sign chart. All right. Pick some extreme values. If I stick in negative 1,000,000, we got negative there. If I stick in 0, I get 1, which is positive. So we can see that relative min happens at negative 1/6. And to find the relative min, we stick negative 1/6 into our velocity. V of negative 1/6 equals negative 1/6 squared is 1 over 36. 3 divided by 36 is 1 over 12 plus negative 1 over 6 is negative 1/12. So the minimum velocity is negative 1/12, no units, because the acceleration changed from negative to positive. This last question, when is speed increasing? Pay very careful attention when you get that wording. Speed does not have direction in it. Velocity does. So when you're looking purely speed, you're looking at getting faster or slower, not worrying about the direction. So what we need to do is we need to combine our two sign charts, our acceleration sign chart and our velocity sign chart. All right, so critical numbers were negative 1, negative 1/6, and 0. On the velocity, we went positive there and there, negative everywhere else. On acceleration, we went negative up to 1/6, then positive after. Now, if you look at what's happening in this interval, our speed or our velocity is positive, but our acceleration is negative. So that means we're going in the positive direction, but we're accelerating toward the negative direction. So speed is decreasing. If we look at what's happening in this interval, we're going in the negative direction, and we're accelerating in the negative direction. So speed there is increasing because we're negative and getting more negative. All right? If we look here, again, our velocity is in the negative direction, but we're accelerating in the positive direction. So here we're negative, but we're getting less negative. So in this one, speed is decreasing. In the final interval, we're going in the positive direction, and we're getting more positive. That means where speed is increasing. So overall, our speed was increasing here and here. In other words, when the sign was the same of velocity and acceleration, our speed was increasing. So our speed is increasing from -1 to -1/6 in union with the interval from 0 to infinity. And finally, when is a function increasing or decreasing? When the derivative is positive, it's increasing. In other words, the values get larger from left to right. We're decreasing when the values get smaller from left to right. And the test is the first derivative is positive for increasing, and the first derivative is negative for decreasing. And a final question, just to kind of throw you for a loop. State the intervals of increasing and decreasing from the following chart. I put this question on here because of what's happening here. The correct answer, we are increasing from -infinity to 4 in union from 12 to infinity. And that's because even though there's a horizontal tangent there where it's not positive, if you go from left to right, it increases into 2, it increases out from 2, so it has gotten bigger from left to right. So that's why we don't put -infinity to 2 in union with 2 to 4. You go right through the 2 because it is increasing at 2, because 2 is larger than the point to the left and smaller than the point to the right. And then there's only one spot in here that says decreasing, and so that would be 4 to 12.